In this discussion video, we are actually going to backtrack a little bit and do an example problem from 3.1. So this is something that involves finding a tangent line to a function that goes through a point. Okay, so if you're watching this after watching a section 3.4 discussion video, you're in the right place. It should be after a chain rule 1. All right, so this example says, find the equations of all tangent lines to y equals x squared minus 4x plus 1 that go through the point 1 comma negative 6. And in this discussion, I'm just going to talk about getting this thing started. All right, so I want to first give you 3 minutes to try the problem. 4, 3, 2, 1, pause it, and really try this question for about 3 minutes. This is a great conceptual question. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. So there are a few things that will help me sort of visualize what's going on. It's really tempting to say, wait, I have this function and I have this point. Doesn't that just mean like this point is on that graph? So I'm just trying to find like the equation of the tangent line. Like maybe I have some curve and this point is on the curve, 1 comma negative 6, and I just want the tangent line like this that goes to that point. But I got to be careful. Nowhere in the problem does it tell me that this point is on that graph. In fact, if I were to plug in x equals 1 into this, the y value is not negative 6. The y value ends up being 1 minus 4 plus 1 ends up being negative 2. So this point is definitely not even on the curve. All right, so to visualize this equation, notice, is a quadratic. So its graph is a parabola. Its graph is going to be a parabola. So to help us draw this, it's going to be useful to remember the vertex formula. I'm going to try to draw a fairly accurate picture. So the vertex formula says the x-coordinate of our parabola of the vertex is negative b over 2a, where I use ax squared plus bx plus c. So I have negative, and then my b is negative 4 over 2a, and the a is 1. Simplifying this, we get 2. That is our x-coordinate. And if we plug that into this equation, our y-coordinate is, let's see, it's 2 squared minus 4 times 2 plus 1, which is negative 3. All right, so now we know the coordinates of the vertex. Let's draw a rough picture. So I'm going to draw some axes. And because the leading coefficient of this x squared is positive, it's going to be an upward facing parabola. So let's draw this vertex at 2 comma negative 3. So maybe that's somewhere here. 2 comma negative 3. And I'm going to draw an upward facing parabola that goes through there. I can tell that the y-intercept of this thing is going to be some positive number, because if I plug in 0 for the x value, the y value is 1. So in fact, I know the y-intercept is going to be 1 here. Okay, and let's draw the point 1 comma negative 6. So 1 comma negative 6, maybe that's somewhere here. 1 comma negative 6. All right, so at this point, if you didn't quite get this far before getting to a point where you have a picture, I want you to do a quick pause now for just 1 minute and see if you can draw a rough sketch of any tangent line that goes through this point 1 comma negative 6 that seems like it'll be tangent to this parabola. So 4, 3, 2, 1, quick pause, just a minute. See if you can draw any tangent lines that go through that point that are tangent to our curve. All right, so hopefully you did that. Hopefully you were able to draw these tangent lines. So one of the tangent lines, it turns out there's 2. It might look something like this, and there's this point where they'll meet just ever so slightly and be tangent, and then it continues onwards. All right, and then there's going to be another line that instead ventures kind of this direction, and then it'll be tangent somewhere here, and then continue onwards like that. So it seems like there's 2 spots like this. All right, and I'm going to label the coordinates of this point where they meet. I'm going to call this x comma y. So it would be nice if we can figure out where that point x comma y is. In this case, there's 2 possibilities where it could be. Because if I know 2 points on the line, 1 comma negative 6, and this other mystery point, I'll be able to write down the equation of the line. All right, and one key thing about this is this line is tangent to the curve. So maybe if we can find the slope of the tangent line, that'll be useful. Because the slope of the tangent line is the derivative. So the derivative of y is 2x minus 4. This is going to represent the slope of the tangent line. And I mentioned at the start of the problem that I was just going to get it started. So this is the point that I wanted to get up to. From here, I want to leave it for you. There's still a key step left to uncover, and that's where I want to leave it. If you were having trouble sort of getting it started, that was the point of this video. But I want to leave room for you to try it and see if you can develop that insight about, well, where do we go from here? And after you try it a little bit longer, if you have questions, definitely use our resources for help. Come ask me in office hours, come to SLC Tutoring to ask about it.